So once we are through with goal definition and scoping, the next step is the inventory analysis. So what is an inventory analysis? It's basically an incredibly painstaking job of listing all of the material, all of the energy inputs that go into a product or process or system. It's also maintaining an equally painstaking list of all of the solid waste, liquid emissions, and gaseous emissions that are occasioned because of your processes. For even a simple product like a pencil, the list can be very long. Imagine an automobile or a jet engine. It's incredibly detailed and it's very painstaking. And you do this for the entire life cycle. So in this phase of the LCA, all relevant data are collected and they are organized. Now, without a life cycle inventory analysis, there is no basis for comparative analysis. Comparing something as simple as regular pencil versus mechanical pencil to comparing an electric Chevy Volt to a traditional gasoline-powered Chevy Celebrity. I'm not sure they make Celebrity anymore, but to give you an example, these are, as you know, Volt and Celebrity are very different vehicles from perhaps different era. But if you do a painstaking inventory, you're coming closer to some kind of parity for a comparison. Without that comparison is mindless and meaningless. It's apples to oranges. So the steps involved in an inventory, how do you do this? Now, it may be somewhat easy for a regular pencil, but if you're talking about an automobile or even a part of an automobile like an engine cylinder, you just can't stare at your product and start reeling off information. So what you need to start with a flow diagram or a process flow diagram. So a flow diagram, you start with the flow diagram, and based on the flow diagram, you determine what kind of data you will need. Collect the data and then analyze it. So that's what is involved in inventory analysis. Now the question then is, what is a flow diagram, right? So let's talk about that. And we'll take a look at an example of a flow diagram. So a flow diagram or a process flow diagram is simply a qualitative graphical view of the entire process, spanning the entire life cycle of a product or process. It's just a graphical, it's a picture, right? And it basically looks like there are a bunch of boxes connected by lines with arrowheads. So those boxes typically represent different processes or stages where processing takes place. The lines and arrowhead indicate material flow and its direction. As an example, we have here a process of making footwear, leather footwear, right? So you got these boxes, and then you have these lines with arrowhead. The first box here is cattle raising. In this case, it's they're getting hides from cows and from goats. You also have the lace for the footwear, right? So that comes from agriculture and textiles. So agriculture is a big box. I mean, you're planting the plants and helping it grow. Then it's harvested. It's made into textile. In textile, there's so many processes that goes on. So each box represents a process. The line with an arrowhead shows the direction of material flow. So this kind of gives you a snapshot of what goes on in this process of making a footwear. So now when you draw a flow diagram, the main goal is to give an overall view of the process spanning its entire life cycle. You don't have, the amount of detail you provide is somewhat subjective. You just need to make sure while it captures the essential aspect, it doesn't overwhelm you. So how do you draw this diagram? So you start off with the main process. So if I'm making engine cylinders, well, engine cylinders are made by a metal casting process. So that's where I start. Then what do? I go a step ahead and a step that follows. The step ahead basically may be a steel melting process, which gives me liquid uh, steel to be poured into a mold. And similarly, another step ahead may be a mold making process, where molds are made to be then dried and poured. The following process may be shaking of the mold to release the casting and then cleaning up the casting. So start with your main process, go a step ahead or two ahead, and then also go a bunch of steps that follow it. And then add all of the relevant information at each step or stage. What are your inputs, what's your material, what's your energy, what goes out, and so forth. And then combine processes. So that's how you do this. So once you get to this point, you would have a sense for what kinds of data you need. And the data you need are very many and not always similar in kind. There are data that you measure. So you have instrumentation or equipment operation logs, purchase data. These are things that are actually measured in your facility. There are others that are modeled. We may have a formula for predicting how much energy is consumed when you melt a ton of steel. So that's called a modeled data. We also have sample data. Sometimes we may not measure each unit of production because we make too many. We may just sample about 10 each day to get a sense for what's going on. Sometimes it may be non-site specific. It may not be measured at your plant, but we can get an aggregate for all ready-mix manufacturers in Texas, as opposed to Mr. X ready-mix site. Some of these may be vendor data. Vendors who sell you stuff can give you information about this new piece of equipment, how much energy it consumes, how much material it consumes. So there are different kinds of data. So where does the data come from? Well, the first is what is called primary data. You produce it. That is, you measure it, so to say. It could be, like I said, from your purchasing or sales data. You bought so much material on a monthly basis. That would be a source. The other is you are running, you have measurements within your plant. You have energy meters, flow meters that give you data. How much gas have you consumed of a particular nitrogen? How much of steel have you consumed? How much electricity have you consumed? Steel would come from purchasing data, whereas electricity and gas usage would come from your actual meters. There could be equipment operating logs that provide you this kind of information. So, the second type of data is called secondary data. This is, you're not collecting it, somebody collected it for you. This could be scientific studies, government reports, or technical reports from vendors, such as what? Well, you have the US Department of Commerce that can put out data for energy consumption in steel industries. Or you could have the US Bureau of Mines that gives you data on how much energy is consumed in extracting a ton of coal. So you do not provide it, but you have this bigger agency that is working with many people put this together. Or you could have EPA put out information. The third is tertiary data, which is compilation of data that others have produced to make for a much larger database. So you could have government sources, private sources, scientific journals, etc. They are all combined together. For example, the National Ready Mix Concrete Association may pool together a lot of data. You could also have the US Department of Agriculture pull data from various state and private dairy, ranches, farms, etc. Pool information. So these are places you go to for your inventory and impact kind of data.